Now,
Hello, my dear students, and welcome to another quick video help session. For this exercise 2.2, I'm going to continue to explain the answers and basically give you the answers. I'm going to write a lot of them down, but not all of them, so you will have to listen, perhaps pause, and follow along as we work through these problems. Remember, anytime you have any questions, my phone number is 870-377-3499. That is my cell phone number. Feel free to call or text anytime. If you call and I'm doing something, like I'm recording a video help session, I won't answer. Leave a message and I'll get back to you. I am working through my email and I hope to have them answered by Tuesday of Valentine's week. By Valentine's Day, actually. And I will post the next one later today or tomorrow here in Grady, Texas, from my home, from my kitchen. It takes me 4 or 5 hours to post a single 15-minute video. So, and that's when I'm lucky, and that's when it doesn't have any, it does disconnects, or when I don't have to start over. If I have any trouble, I'll go up to school and post some more. Again, if you have any trouble, don't hesitate to call or preferably text. Now, we're starting with an examination of elements, and then we'll put the elements together and make compounds in the next assignment. And in this one, we had a table where it said supply the missing element symbols and number of electrons for the following. I'm sorry, when I look at mine, the formatting does not come across. It is a little challenging, so do your best when you print out. It depends if your printout does what mine did. It looked good when I posted it. I don't know what happens as it goes through Blackboard, but molybdenum is element number 42, and its symbol is MO, not M. In fact, there isn't an element M, even though many of them begin with the letter M. And being element number 42, it has 42 protons, but the neutral atom also has 42 electrons. It really is that simple. Get you a periodic table. You'll have a periodic table and, open book resources for most of the tests except the midterm and the final, which when you take your test, whether it's one of the online tests or one of the ones you have to come into school for or sit down to take, those test questions will be direct reflections of these assignment questions. With this caveat, this qualification, I may not ask molybdenum. I may ask, another M metal, magnesium, manganese, mercury. Okay, so know the process. You look in the table, you find its symbol, you look for its element number, and that is the number of protons and the number of electrons in a neutral species of that atom. So the next one is element number 19, which is potassium. And potassium is interesting in that it has a Latin root kalium, so its abbreviation is K. As an aside, it's still used in the medical field. If you have hyperkalemia, okay, that's too much potassium in your blood, which is, we like potassium and we kind of prefer it over sodium, but it can also affect nerve signals, transport across the cell membrane, heartbeat, regulates all kinds of things. So you do need to keep it within tolerance. Anyway, you'll still see the Latin kalium used in some instances. Titanium is a transition metal, capital T, little I. Remember, these are symbols, not abbreviations. And it's element number 22, so it has 22 electrons. B, of course, stands for boron. up there near the top of the table. It's element number 5. It only has 5 electrons. So it is this simple. You find the element symbol and you look at its name, or you find its name and you look up its symbol. Element 53, if you look in the table, is iodine, which has the symbol I. Samarium, that's an interesting one. I want to say it's down in the lower 2 rows. Even I don't know all of these by heart. You will always have a periodic table. When Mendeleev invented the periodic table, or first developed the periodic table, he did it so that his students wouldn't have to memorize the elements. And it was easier back then. There were only 40 or 50 of them. Now we have 118. And a lot of them aren't very common. A lot of them have only been produced in fleeting amounts. Unmeasurable masses of them. 50 atoms of them. 20 atoms of them. And so, I have worked in universities, colleges, high schools, commercial chemistry labs, research labs, all around, government labs, and in every lab, up on the wall somewhere, there's always a periodic table. And you ask a chemist, a question, you'll see them look up at the table to see where something's positioned, or, trying to do some properties of an element. So you will always have a periodic table when you're testing. Samarium, helium is He. It's element number 2. Okay? And number 14, I didn't look up. I don't have a periodic table here. You do it. Okay? I'm trying to think where that would be in the periodic table, but I'll think in a minute. Okay, so lanthanum has the symbol La. It's element number 57. It has 57 electrons. IR is iridium, like the satellite, the failed satellite sat phone company, iridium. It's element number 77. Aluminum is abbreviated AL. It's element number 13. What do I have next? 80, speaking of M metals, is mercury, but it's abbreviated Hg, mercury, one of 2 liquids in the periodic table, and the only liquid metal at room temperature. Silicone is Si, right there below carbon. It's element number 14, so it has 14 electrons. Fluorine is element number 9. They're in group 7. It's a halogen. And don't forget, even though we say fluorine, it's the U for first. Fluorine. Okay? Fluorine. And beryllium. There's no such thing as a beryllium sphere if you saw Galaxy Quest. But anyway, it's a very simple metal, and it's commonly found in emeralds. It gives emeralds their green hue. In fact, another name for an emerald is a beryl. Just the beginning of that. And finally, element number 3. It's one of my favorites. It gives a brilliant crimson color in a flame test. It's actually a good first-line drug with some interesting properties in the human body for treating depression. Is element number 3, Li lithium. So, that's your first page. Like I said, I may not write all these down because I want to make this quick. If you're having trouble following, pause, rewind, and replay. So, the third question says, give the symbol for these elements, all of which exist as a single isotope. I did not know that for these. But Beryllium is Be. Remember, the first letter is capitalized, the second letter is lowercase. If you have a two-letter symbol, every element has a one or a two-letter symbol. They're symbols, not abbreviations. So it doesn't always make perfect sense or follow perfectly. Ruthenium is named after Mr. Rutherford, who gave us the nuclear structure of the atom in his famous gold foil experiment, is Ru. Phosphorus is P, 1P. Aluminum, we already had it over here, is Al. Cesium, it's not Ce, it's Cs. Praseodymium is Pr. Cobalt, there in the transition metals, is Co. Yttrium, one of the Scandinavian metals. You know, I always think Yumpen Yemeni. You know, here's this metal from Scandinavia, being of German and Lutheran descent. And I hear those voices of my ancestors talking about these metals. Sweden, Norway, and the Scandinavian countries are beautiful, rugged countries filled with mountains and deposits of all these weird metals. You know, even Madame Curie, when she was isolating radium, took ore samples from Scandinavia, tons and tons of them, to make, you know, a tiny amount, a gram or so of radium, which ended up killing her because it's so radioactive. But my point is, you know, they have wonderful resources there. And so you'll see a lot of the elements named scandium, for example, with Scandinavian names. Those were all discovered in the Scandinavian countries, Finland, Norway, Sweden, etc. Anyway, yttrium is Y, and arsenic is As. Going on to number 4. Fluorine, the U first, is just F. Helium is He. Terbium is Tb, not Te, because that's tellurium. Anyway, it's Tb, terbium. That's another one of those Scandinavian ones, I believe, too, or from that same group of discoverers and scientists. Iodine is a simple I. Gold is from the Latin aurum and is Au. Okay. Scandium, you can guess whether or not that's a Scandinavian metal, is Sc. Sodium is Na. Niobium, what a great name, reminds me of the Matrix and Niobe. But niobium is Nb, and manganese. Watch out. Students always trip up on this one between manganese, Mn, that's your answer, Mn, and magnesium, Mg, over there in group 2. So don't mix those up. Now, the next question asks for isotopes of iodine-131 and cobalt-60, 2 commonly used medical isotopes. This is used to treat thyroid cancer. I forget what cobalt-60 is used for. I think it's just a tracer, but I'm not sure. There are all kinds of medical isotopes that are used in very sophisticated processes and procedures, especially in treating cancers. But iodine-131 has a mass of 131, but iodine itself is element number 53. So it said how many neutrons, protons, and electrons? Well, it's element number 53, so it has 53 protons. And it also has 53 electrons. And for neutrons, what do? We ignore the mass of the electrons. The protons and neutrons each have a mass of 1. If my total mass is 131 and my protons weigh 53, the number of neutrons is the difference between them. And so that would be 78. So there are 78 neutrons. Okay? Use the calculator if you have trouble with it. And cobalt. Okay? Cobalt is element 27. That means, I'm just going to put P plus. P for proton, plus for positive charge. It has 27 protons, E minus. E for electron, minus because it's negatively charged. It has 27 electrons, and 60 minus 27, okay, 60 minus 27, total mass is 60. That's the mass of the neutrons plus the protons. We know the protons are 27. That means my neutrons must be what? 33. So that's the number of protons, electrons, and neutrons. Now, the next one is a little bit more complicated, and I'm sorry. This is your obligatory calculate the average isotopic frequency, or calculate the average atomic mass from the isotopic frequencies. You can work backwards or forwards through this. And this was a big deal, I don't know, 100 years ago. Chemists were determining, probably not 100 years ago, probably in the 50s and 60s, when mass specs became more common and they could determine isotopic ratios. And so they went around calculating the average atomic mass of every element very carefully. And they're so proud of what they did, and it is an enormous accomplishment, that they decided that future generations will understand how those numbers were achieved. But here's the important thing. All you need to do is look in the periodic table, and it will tell you the average atomic mass. But here's how it was derived. They're saying that copper has two main isotopes, copper 63 and copper 65, and that their abundance of copper 63 is 69.09%, and the isotopic abundance therefore of copper 65 is 30.11%. Okay, so 69, 0.09 and 30.011%. That's correct. Now, the way you calculate the average is you take 63, 30%, or a fraction of 0.3011 of the copper weighing 63, plus some of the copper weighs 65, specifically a fraction of 0.6909, and put that into your calculator. And if you do that, when I did it, I got 63.098 grams per mole. We're not there yet, or atomic mass units. For now, if you look on your periodic table, you'll see that this is a unitless value frequently. And it's because we're not ready to talk about the proper units, or the units that are useful. And the other ones are, I won't say made up, but based on the fact that an atomic mass unit is 1/12 of a carbon-12 atom. Anyway, this says, does this agree with the value in my periodic table? And I have last year's Flynn Scientific Periodic Table of the Elements, and it said that copper has an average atomic mass of 63.546. So it's really 0.4 of a gram, half a gram off. This was just an exercise, I guess. I don't know if they were using real numbers or just throwing that out there. The point is, when you calculate average atomic mass, you do it based upon isotopic composition. And you have to determine all the different isotopes, their mass, and their relative proportions. So it is what we call a weighted average in regular math. Okay, let me go on. And I don't have a lot, so I'm going to quickly go through these. Classify each element as a metal, semi-metal, or non-metal. If metal, state whether it is an alkali metal, an alkali earth metal, or a transition metal. And those aren't the only types of metals. So it runs down: iron, tantalum, sulfur, silicon. So iron is a transition metal. Okay? Tantalum is a transition metal. It's in group 5B. Sulfur is a non-metal. I don't even know why that's in there. I guess they didn't say. Oh, they said whether it's classify it first as a metal, semi-metal, or non-metal. And this question that I got from some book source somewhere called the metalloids semi-metals because they're the metals you use to make semiconductors. Okay? The difference between a metal and a non-metal is metals are good conductors, non-metals are poor conductors, and the metalloids along that stair-step line in the periodic table, they may be good conductors, they may be poor conductors, they're semiconductors. So some people use the term semi-metal. So, sulfur is a non-metal. Silicone is a metalloid or a semi-metal. Chlorine is a non-metal. It's a halogen there over there in group 7. Nickel is a transition metal. It's a metal, you know that. Potassium is a metal, and it is an alkali metal, group 1. Radon is a noble gas. It's over there in group 8A. And zirconium is a transition metal. You may have heard of ultra bright toothpaste with zirconium to brighten your teeth, or you may have heard of cubic zirconium, which is a very hard crystalline form of zirconium that people substitute for diamonds because it can be laboratory made, yet has a lot of the fire and properties of diamonds. If you get an engagement ring for Valentine's Day coming up and you want to know whether it's a real diamond or cubic zirconium, see me and I'll show you a trick to tell them apart. Do not cut glass with your diamond. You can hurt your diamond doing that. Yes, it will cut glass, and a good industrial diamond cutter is a good glass cutter, but cubic zirconium will cut glass too. So, which of these sets of elements are in the same period? These are perfect test questions. They're already set up as test questions, except they have more than one correct answer. Don't remember the answer. Remember the process, because I'm going to change up what elements are there. The next one says, which of these sets are in the same period? Potassium, vanadium, and ruthenium. Periods are the ones going across in the table. 1, 2, 3, 4, 5, 6, from the top down. Okay? So, potassium and vanadium are period 4, and ruthenium is period 5, so that doesn't count. Lithium, carbon, and chlorine are group 2, lithium's group 1, but it's period 2, carbon's period 2, and chlorine is period 3, so those are not in the same period. Sodium, magnesium, and sulfur are all period 3, and so that's a correct answer, but also the next one, chromium, nickel, and krypton are all in period 4. They're all in the same row going across. It's that simple. And that means a lot when we start talking about energy levels and the electronic structure of the atom in a chapter or two. Which these sets are in the same, of elements are in the same period? Question 5. Barium, tungsten, and argon. Period 6, and period 3. Yttrium, zirconium, and selenium. Period 5, period 3. Potassium, calcium, and zinc are all period 4. Ding, 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 ding. So circle C, or answer C. Scandium, bromine, and manganese, period 4, period 4, period 4. Ding, 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 ding. And for the next one, it says, which of these sets elements are in the same group? That's the same up and down group or family. I like to use they're numbered different ways. I don't like the Arabic numbers, 1 through. I like the Roman numerals. Group A, 1 and 2 on the left, a break with the transition metals, 3 through 8 on the right, and then the group B elements or transition metals in the middle. So, which are in the same group? They're in the same row, up and down. Sodium, rubidium, and barium? Nope. 1, 1, and 2. Group 1, and Group 2A. Nitrogen, phosphorus, and bismuth? Yes. They're all in Group 5A. Copper, silver, and gold. they're all in group 1B. And by the way, they belong to a group. They have a lot of similar properties, and those are called the mint metals because they're used to make money, mint money. Although we don't use silver coins, gold coins, or really even copper coins anymore. So C is also a correct answer. Magnesium, strontium, and samarium are in different groups. Which of these sets of elements are in the same group? Iron, ruthenium, and osmium? Yes. So A is a correct answer. Those are all in group 8B. Nickel, palladium, and lead? No. You can look in the periodic table and see they're not all in the same up and down group. Iodine, fluorine, and oxygen? No. Iodine and fluorine are group 7. They are halogens. Oxygen is a chalcogen, though most people don't use that term, right? It's used a lot more sparingly. It's in group 6. But the last group, group D, not group D, but the answer D, boron, aluminum, and gallium are all group 3A metals. Now, let's do this last 2 questions and we're done. Which element, indicate whether each element is a transition metal, a halogen, or a noble gas. So I'm not going to write these down, but I want to do some explanation. So a transition metal are the group B metals, I guess less true, the lanthanides and actinides, and yet still they can have multiple valences. But manganese is a transition metal, A. Iridium is a transition metal, B. Fluorine is a halogen, no. Xenon is a noble gas. So fluorine is a halogen, xenon is a noble gas. Lithium is an alkali metal, okay, group 1A, so that doesn't count because they're saying indicate whether each element is a transition metal, halogen, or noble gas, and lithium is none of those. Carbon is none of those in the next answer. For G, zinc is a transition metal. Sodium is not a transition metal, it's an alkali metal. Tantalum is a transition metal. Hafnium is a transition metal. Antimony, that's always a hard one for students. Its abbreviation is SB. Sorry, I don't remember its Latin root because I don't encounter antimony a lot. But there were some glass. It used to be incorporated into glass, and it's also used as in the semiconductor industry. But it's a metalloid or semi-metal. And cadmium, kind of toxic. You shouldn't be working with that. Although we do every day, right, with our nickel cadmium batteries, and we toss them into the environment. Recycle your rechargeable batteries. Anyway, that is a transition metal. Now, there's a little picture of a periodic table. I like this only because it was a really good test question. I would label these A, B, C, and D. I didn't print this out in color, but it says which the elements in color in the periodic table below is most likely to exist as a monoatomic gas. I don't know what color it is, but it's the one on the far right. That's argon. And which one exists as a diatomic gas? Well, all of the halogens tend to exist in diatomic form. If your name ends in "ene" or "gen," you're diatomic. Hydrogen, oxygen, nitrogen, and what? Fluorine, chlorine, bromine, iodine, and astatine. But chlorine, this 2 rows, 2 down and 2 over from the right. Which is most likely a semi-metal? That would be this arsenic on the stair-step line. Again, I'm sorry I didn't print this out in color, and I don't have it in front of me right now to look at. But it would be the next one over is arsenic. They seem to be going right to left. And which of the following is a reactive metal? I would say both this rubidium and this 1, 2, 3 down on the far left. Those are alkali metals and alkali earth metals. I don't like the term reactive metal, but they're defined as metals that react with water to form hydrogen gas. Okay, and they both do that. So those 2 would count. The other colored square is a transition metal and it doesn't ask about that. So there's your answers for this one. I'll post this and the answers to 2.2 presently, in the time it takes to upload this from my kitchen, and if not, uh, I will have them posted and not just linked to my YouTube channel, but posted directly into your Blackboard when I go up to the campus and use their good fast computers there, which by the way you can use and use in the Student Study Lab anytime. So until then, stay safe, and we'll see you in the next video help session down further in your Blackboard shell. Goodbye now.